In this video, we will explore some IB exam about the first derivative and the graph. For number 1, A, B, C, D, and E are the points on the curve y equals f of x. Describe the gradient of the curve. When you talk about gradient, which means the derivative, in passing from the point B through point C to point D. So you will do from B at B. Since B is a relative maximum point, therefore, you will see the derivative equal to 0, or you could say gradient equals to 0. Then from B to C, did you see the graph is decreasing? Therefore, your derivative will be less than 0. Or your gradient is negative. At C, this is a relative minimum. Therefore, your derivative equal to 0. Then from C to D, since the graph is increasing, therefore the derivative of f of x is greater than 0. At D, this D is a stationary inflection point. Therefore, you will get the derivative equal to 0. Let's go to B. D has a coordinate A, f of A. So we have A, f of A. And the x-coordinate at E is a plus 4. So here's a plus 4. Then they ask you to write an expression for gradient of the line segment DE. For the line segment DE, the gradient means the slope. You have to use y2 minus y1 and then the x2 minus x1. We already know this is your x1, y1. So here's x2. How you do the y2? Y2, you will substitute the a plus 4 for this x. So you get the f of a plus 4. In other words, we know the x2, y2 will be a plus 4 and f of a plus 4. Therefore, we plug into this formula, you will get the f of a plus 4 minus f of a over a plus 4 minus a. So we simplify, you will get the denominator is 4. Then f of a plus 4 minus f of a. Yeah, this will be the answer to B. Now let's go to number 2. The letter A to E are placed at points on the curve y equals f of x. What's the gradient of the curve y equals f of x at the point marked C? You could see for this C, that's a local maximum point. Therefore, the derivative, it will be equal to 0, which means the gradient of the curve equal to 0. For number 2, in passing from point B through C to point D, what's happening to this derivative? Is it decreasing or increasing? So we could see from B to C. The graph is increasing, therefore dy by dx is positive, and it's increasing. The graph is increasing, or you could see the function is increasing. Then from C to D, dy by dx is less than 0 because it is decreasing. Let's go to number 3. A function f is defined for -4 to this 3. So domain is given. Then the graph has a local maximum when x equal to 0, local minimum when x equals -3 and x equals 2. So we could say this point, that's local maximum or minimum points. For number 1, write down the x-intercept of the graph of the derivative of function f. When you talk about the derivative of function, that is f prime of x. We want to get the x-intercept of this derivative function, which means you have to set up the function equal to 0. So where you can find the derivative equal to 0, basically is at these 3 points. Therefore, the x-intercept, you will write down the x equals -3, 0, and 2. For number 2, write down all values for x, which f prime of x is positive. When f prime of x is positive, which means the function is increasing. Therefore, you will find the increasing graph for this given function. You could say from here to here it's increasing. Then from here to here it's increasing. Therefore, all the value of x, you will write down interval. This is the one is from -3 to 0. Then union set here from 2 to 3, 2 to 3. For number 3, this one is for number 2. At point D on the graph of f, the x-coordinate is 0.5. Yeah, this one is 0.5. Then what's f prime of 0.5? You will see it's less than 0. Let me add one more question. Find the value of x for absolute maximum and absolute minimum. For the graph, where you can find the absolute maximum, you will see the very highest point is here. That is x equals to 3. You have absolute maximum points. So where you have absolute minimum points is here. This one is absolute minimum point that x equals -3.